So my name is Alok Jain, and I'm based in Hong Kong. I've been working in public transport for last 30 odd years, and public transport obviously is a much very challenging system. So cars are, as we say, it's a one-to-one system. Some of the scenarios that Dr. Taolin painted is car becomes one to many, where you have multiple drivers using the same car, the sharing systems. But think about having a system which is not just one to many, but one to any, which means anybody can use it, right? It can be a random person who is visiting your city. It can be somebody who takes the bus every day. So it starts to create a completely different kind of complexity in the system, and the challenges are completely of a different nature altogether. As a part of this whole conversation on smart city, there is a worldwide push and recognition of the fact that car-based cities are not sustainable. If we want to move the people in a city, we need to focus on the mobility aspects, and where public transport plays a very, very important role. Car-based systems, because of fundamental physical requirements in the city, they are not certainly possible. And even with public transport, if you see most of our cities around the world, they were really not designed for so many vehicles. We were supposed to live in much smaller social spaces. If you look at older cities and how they evolved, and we are now trying to fit in all these complex vehicles and cars and lot many people and higher density into a very small space. So there is a whole challenge of utilizing our space in a much more efficient manner. So, of course, we have larger vehicles, we run trains, buses, and all these things. But then technology kind of enables us to take it to the next level. And that is what we are going to talk about. And this conversation has really become one of the major topic theme these days in the post-COVID scenario. Because in COVID, we are talking about social distancing, and people are avoiding public transport. Places like London, they have even said, don't use public transport, which is really not sustainable, because the cities can't survive without having public transport. So answer here is, what can we do, how things can alter and change, and in a new world, and we can revive our cities with technology and public transport. So next. So in the COVID-19 scenario, we see a whole new range of data collection methods, especially with tracking of movement. Movement of people is one of the main ways where the infection has spread. So, and then there's a lot happening on the tracing side. So there is on the documentation side, where you are, what kind of a disease status it is, modeling of how it is going to spread with the movement of people, with kind of contacts that is created, and of course, who you are coming in contact with. So if you see, all these three things require one fundamental thing, is identification of the person. Because without that, you would not be able to connect the dots. So, and a lot of apps have come. What that has fundamentally done is that created a huge amount of trust issues. So you install an app on your phone that protects you, but that at the same time allows you to share a lot of data in public domain with authorities, with politicians, with police, with somebody else, which can hack into the system. And that is a very big issue at the moment. And this morning I read an article and how Singapore, who have done a nice contact tracing app, but people are not using it primarily for the purpose that people don't trust the app. People don't trust how the data will be used. People don't trust how the data will be protected. So next, CK. So if you see that there are a lot of these type of apps that are going around, which are giving location specific information, which are either doing P2P or P2, this whole cloud kind of systems. And there are a lot of risks that people are highlighting with respect to civil liberties, data security, trust, how it will be utilized, and those things. Next. So public transport is also, so from a, not just from a customer side, because if you see cities like Hong Kong, Singapore, we have millions of people actually using public transport almost on a daily basis. Hong Kong has daily 13 million trips every day, and out of that, 90% of the trips are on public transport. In Singapore, roughly 70% of the daily trips are on public transport. And Maoka-san was explaining earlier how every vehicle of today is embedded with number of sensors. So I can tell you, a bus today has a couple of hundred sensors. A train could possibly have over 1,000 sensors. And you can imagine, when there's so many sensors, the amount of data that is being generated is just enormous. I mean, I can give you a simple example that when we install a CAN-based system on a bus, a telematics device, it can generate more than 1 million transactions a day. And if you're running, say, 4,000 buses, the amount of data that and I'm not even talking about camera information, these are simple transactional information. These are millions of transactions that are coming per vehicle per day. And if there is no way humanly that we can analyze this data on a spreadsheet or using simple data tools. So we need to go towards better tools, and we talked about edge computing earlier, so onboard computing, edge computing, and those have to be done. Another area which needs to be done is how we store this data, because there is no way we can keep all this data. So we also need to look at data expiry. Some data has a value for only for a few seconds. Some data has a value for a few minutes. Some data has a value for years. And you need to decide what kind of data to be kept for how long. So this whole data governance that needs to be addressed. But when we do all these things, when we have all this data, we can not just analyze how people behave in a system, but we can also create responsive systems which can adjust itself to meet your customer travel patterns. Next. So traditionally, if you see, public transport has been very low tech, and we rely mostly on very simple websites, and people don't even look at a phone when you go to take a train, because it's always there, or you just stand at the bus stop and you look at the buses coming, and basically you have this reliability and trust. That is the big issue. A lot of new mobilities that have come in, all your micro mobility, ride sharing, ride hailing, all those are mobile driven systems where you literally control the vehicle and you know exactly where it is at any given point of time. So it has reduced a lot of anxiety around the world. So the Ubers and the Lyfts of the world have really taken are redefining transport. So public transport has also recognized this value, and there's a lot of upgrading or upskilling that is happening in public transport world, and we are trying to put everything together on single platforms. Next, CK. So the concept that has come now is what we call mobility as a service. So it is one platform where the entire mobility solution is available to people as a single solution, and you interact it as a person. So everybody can have a customer account there. You can have your preferences. You can have your value propositions, and it can be offered like a mobile phone package, a subscription. So today you buy a when you subscribe to a telecom package, you buy a certain amount of gigabytes of data, certain minutes of call. I don't think anybody even knows how many minutes they have actually consumed, or how much data that they have consumed, unless you go and deliberately check it. And we don't pay per call. So public transport is moving from this pay-per journey model to these subscription-based models. And this mobility of service, this concept is kind of enabling a collective aggregation of data and sharing of data between different operators, and then we're putting a value proposition to the customers. Next. So integration is obviously the big thing, and it is happening at all levels right now. At the governance level, how public transport is organized in the cities, ticketing systems. In most of the developed world now, you use a single ticketing medium that can be used all across the transport modes. So Singapore has TransLink, Hong Kong has Octopus, London has Oyster, and they're also going for open loop systems where you can use MasterCard, Visa card, or even Apple Pay, Google Pay. All that is coming as a part of integrated offering to people. Physical interaction, of course, integration is necessary because they all need to be in one place, convenient to interchange from one system to another system. Information. This has been one of the biggest challenges in the past, how to combine and provide information on a real-time basis to customers of where things are, where different assets are. So once you get off the train, you know your taxi is right there, or vice versa. And this information about your assets was impossible in the past. But with new technologies, with mobile in everybody's hand, all these location specific and a lot of sensors on the train, we are able to correlate these two and put it on an integrated platform and make a better offering. Next. So demand responsive transit. I don't know how many of you actually are familiar with this term, but in the past, you always waited for the bus, you always waited for the train. And that's a traditional public transport where you have demand which is bigger than the capacity. And so you just throw in a lot of capacity at a problem and you run fixed route, fixed line, fixed fare, and everybody just gets on that bus and you know exactly everything is predictable. Nobody has to work out anything in their mind. What is happening in the post-COVID world is that demand has reduced. A lot less people are moving, and they are not moving in the same way that previously people were moving. So demand has reduced and the capacity has become much more. How do you deploy this capacity to the maximum effectiveness? So, and of course, the idea here is, so people will tell you where the demand is, and if we can aggregate in a certain way and organize this demand into a common capacity pool using a demand responsive transit system which aggregates this and optimizes on a real-time basis and takes you from your origin to destination in a specified time with a specified fare. Now, this is really the new world that we are looking at. This is also very fundamentally important when you start to look at providing public transport services in low density areas, rural areas, nighttime, off-peak services, wheelchair users, hospitals. So all those kind of low demand operations on public transport is trying to move towards this demand responsive transit at the moment. But having said that, if you can imagine how complex these operations are. So let's say if I have 4,000 buses, a 4,000 bus operation requires roughly 11,000 bus drivers. And if I take Hong Kong, carries about 3 million people per day. So you're talking about number of variables here, which are just enormous. And you are trying to solve, and of course you add up into geographical, and the assets are spread all over the city. They are not just in one location. So you have a geographical challenge, you have a manpower challenge, you have your vehicular asset challenge, and then you have, of course, the customer demand, which is completely unpredictable and to a large extent even be random. And solving this problem on a real-time basis requires a lot of computing capacity. Next. Another thing that has happened after this COVID is micromobility. A lot of cities are seeing a lot of bicycles, scooters, and they are pumping in data. These are all data-driven systems, and they provide payment systems, they provide location systems, and of course there's a customer account system, a customer management system on the back of it, which allows you to track and interact with the system. Next. So the trend here is that everything is coming around it, and there are people who are becoming mobility integrators, and they provide the solution. So you're not interacting anymore with your bus companies, train companies, taxi companies, who cares who they are, and you're just talking to one aggregator, and that aggregator provides a complete solution, combining your ticketing system, combining your operators, combining your payment providers, everything into one platform. And that's the utopian world that we look at as a public transport system. And it is already starting to happen in many parts of the world. Next. Open data. Now, open data, there's a lot of conversation that is happening about open data. We just heard about closed loop systems because of cyber security. Now, obviously, on a public transport, we are taking the other extreme. We want to open all the data to everybody. So if you go to London, Transport for London data is available to anybody and everybody. And Transport for London, even they don't provide any system, any app, or any aggregation. People are doing the aggregation by themselves. There are 153 apps at the last count in London, which are providing transport information, aggregating this open data, and then making it an offering to people. When you start to do the open data, it opens a lot of new challenges about data ownership, data licensing, data monetization, liability. And again, a whole lot of work that is happening, which is multidisciplinary. There are a lot of lawyers involved in the process. There are a lot of data generators involved in the process. A lot of institutional framework is being changed and challenged at the moment. So a lot of work that is happening towards this data framework. Next. AI. Now, as I said, with so much data that is coming to you, and of course, both in structured format as well as unstructured format, there's a huge opportunity to deploy your tools like AI and machine learning to automate some of the processes, of course, and look at even onboard analytics, AI-driven systems, and then make multi-dimensional decision. And I mean, basic fundamental for AI and machine learning is if your data is multi-dimensional, if it's coming from multiple sources, it is coming at a very high volume and high speed, you have a perfect recipe for putting AI systems. So these are being used to enhance customer experience, to optimize the operational efficiency, for dispatching system, for supply demand mismatches, addressing the supply demand mismatches. We are putting a lot into preventive maintenance. Vehicle breakdown is one of the biggest problems in public transport industry. Your bus breaks down and suddenly you have 100 people standing on the road and with nowhere to go. It's extremely disruptive. So we are now looking at predicting when the components are going to fail, when the vehicles are going to fail, and address the failure before the actual failure happens. Okay. And of course, safety and security systems. Next. So there was a study that was conducted by International Association of Public Transport in 2018 and on this use of artificial intelligence in public transport. And they looked at these 4 key areas and 4 key buckets in public transport that are really something that people should be addressing. Of course, customer excellence, operational excellence, engineering excellence, and safety and security. Next. Some of the use cases I'll quickly go through that are already happening around the world. So chatbots are everywhere now. And chatbots are obviously using your NLP, natural language processing, and deep learning, pattern recognition. Some of the fantastic ones are in Japan, actually. If you go to the JR East or Tokyo Metro Station, you find these little cute toys, which are actually robots. And they provide the customer interface. They answer basic questions at the moment. They tell you where the toilet is. They tell you where the lifts are. But at the same time, at the back end of these cute little toys, there is a huge amount of intelligence that is being developed. Every time you are talking to these robots, the data is being processed at the back end, and you are actually training the robots. And there are people at the back who look at when the answers are right and wrong and how to fine tune the system. So it's a constant training process, and they are getting better and better in responding to most of the fundamental questions. As a public transport operator, I can tell you, one of the fundamental challenges is when you have a new call center employee, it takes them sometimes 6 months before they even know about your system, because your systems are so vast. You're probably running 4,000 bus stops, and nobody can know where all of these things are. These AI-based systems at the back end allow these people to get on board because they use the customer voice recognition and they put this data and answers right on the screen of call center. So you're still talking to the humans, but they are assisted by these robotic processes at the back end, which then allows them to give better answers, to give better information to customers. Yeah, next. On the allocation side, you need to know where people are moving, and how you can deploy your capacity. So there was this example, this was done in Casablanca by RATP, which is one of the biggest French operators. And they input all these operational data, ticketing data into an AI engine. And in the end, they could achieve a 10% increase in capacity of this entire delivery. So with the same number of vehicles, same number of assets, and same number of people, they could carry 10% more people. It's just simple. If you know exactly where your demands are, and you deploy your capacity at the right place, and you become more responsive to those on a real-time basis, you can carry certainly more people. Yeah, next. More journey planners. I think you all use journey planners. Some are very basic ones. Some are now getting very, very smart. They, as soon as, I don't know if you have noticed, but Google does it very smartly. You get up from your seat at 5 o'clock, 5:30 in the evening, and Google knows you are going home. And then it will tell you what the traffic situation is, what are the modes of transport. And we are even moving to a stage where some of them will tell you that if you left 10 minutes late, you will probably reach about the same time. So you won't get stuck in traffic. So it's a real-time planning tool. So people are happy by this, but what we are achieving here on this at the city level is we are optimizing the capacity of transport network by giving right information to people. So this is a behavioral nudge to customers, which allows them to spread out and use this capacity optimally. So you move more people with the same amount of space. Next. Personalization. So again, this is really, this whole package is part of this personalization, where customers, they know what is happening, what they want to do, what their preferences are, and accordingly you give them a decision-making power for different kind of applications. Next. On the operations side, next. You work much better scheduling. As I said, when you have your assets all over the cities with so many people, and your drivers can fall sick, somebody doesn't show up, somebody is not feeling well at any given time. There's a lot of aberrations that happens in a public transport operation. These AI algorithms, they do real-time schedule management, do dynamic scheduling, dynamic dispatching, that allows you to adhere to the schedule, allows you to respond to disruptions, and again, in the end, create better user experience. I mean, one of the reasons why people don't use public transport is because you don't trust it. You think that it is not there. My car, at least I know, is right standing there. I'll go down and I'll just start the engine and move. And public transport, you don't know how long you have to wait, and these are the things that we are trying to address in public transport using modern technological tools. Next. Maintenance side, again, we're trying to just, so we used to do a lot of preventive maintenance, so which is over-engineered solution. We replace tires, we replace a lot of components and equipment before they fail, because statistically we want to be, if we are 90% accurate, want to be 90% reliable, that means we are wasting 90% of the capacity of the equipment in a way, right? What we are doing now is we are moving to condition-based monitoring. We are looking at predictive maintenance, because every equipment goes through a different operating cycle, and we try to address it on a equipment and a component by component basis, and then predict when they are going to fail based on their life cycle conditions on what they have been through. And that can actually increase the equipment life by up to 30-40% very easily, which is a huge amount of money. So if you look at public transport operation, 60% cost is about manpower, and 30% is maintenance or expenses. So it's a huge amount of expense that you can reduce in public transport operations. And ultimately, end of the day, it is the customer who pays for this thing, or government pays for this. So you bring down the cost, you make it more sustainable. Next. Behavioral coaching. This is one of the new areas of research. So because all the public transport operation depends on the drivers, and the drivers determine your safety, determine what fuel consumption is happening, how vehicles are being driven, how braking is being done, how acceleration is being done. All that we are now using AI-based tool to nudge the drivers, measure their behavior, and move their behavior in the right direction. And in many places, and places like Singapore, Tower Transit in Singapore has done some great experiments there, and they have managed to save 6-7% of the fuel just by making their drivers drive better. And so that creates a better environment, better economy, and better solution for everybody. Next. Autonomous vehicle, I won't go through this. It's already been covered on, in previous presentations. But there is a lot happening on that front. But for public transport, we always say this is still a road a bit too far. You don't want to jump to that immediately. We are still watching the space very closely. Next. Digital twin, we heard about digital twin, but again, when we start looking at public transport systems, these digital twins are massive digital twins, and they start right from the planning stage. So if you're building a new railway line, you start building a digital twin before you even start putting a first brick on the wall. You obviously before you start digging. So you created a virtual model, and you can manage your construction progress through this digital twin, and then you go to your operations and basically do the entire total life cycle management using these digital twins. Okay, next. So some of the examples in China, some of these applications are being applied very massively all over the place, and especially on high-speed trains. So currently, there are big plans to put deploy AI-based solutions on high-speed trains in China. They are putting these embedded RFID tags and sensors in train as well as ground. So you're moving asset and a fixed assets, and trying to use this data to build this back into the maintenance system and address the failures. And they want to reduce the cost of maintenance significantly. 20-25% on high-speed rail maintenance costs. So which is a massive saving in operations. Next. On the safety side, accidents is always a major issue. We just saw in Mr. San's presentation that how accidents affect a lot of these the driving behavior, especially when it comes to autonomous driving. But even when it's assistive driving, there are a lot of things that happen because of human error. I think roughly about 80% of the world's traffic accidents are because of human error. So, and next slide. And even with the human error, if you see that if you can intervene 1.5 seconds to 2 seconds before the actual accident, you could have prevented 90% of the rear end collisions, for example. So it's a massive area of predictive area, that if you could predict an accident 2 seconds before the actual accident, you would have prevented the accident. You would have prevented lives, many lives. So many people won't lose their lives. And how to do that is what we are trying to solve today. Is we are looking, so there are three things that happen in an accident. It could be either the vehicle problem, it could be either the driver problem, it could be the road problem, the environment problem. So and most of the vehicles today, public transport vehicles today, they have front-facing cameras, they have driver-facing cameras, and they have telematics devices which is reporting vehicle health literally on a second-by-second basis. Next slide. Okay. So if you combine all these three together, you can create a very active system. And then we are now also integrating the human resource system into the same. So because every driver is not the same, every driver's capability and response time is different. So we integrate your road-based data, environmental data, vehicle data, driver data, and his state of mind, state of condition at that given time, and combine all these to create a predictive risk management framework where we know when he's turning the wheel, what chances he has to make an accident. And if he's above a certain threshold, you give him a prompt either by sound or by vibrating the seat so that the driver is more alert and prevents an accident. Some of the experiments around the world on this one that has happened, the number of what we call near misses. So normally in transport terms, we say accidents is something that has happened, but near misses is what did not happen. And if you can actually study the near misses, you can prevent a lot of accidents. So when we look at near misses, it brings it down by 60-70% just because the drivers have become more alert and they are being assisted by these kind of systems. Next. So yeah, and of course there are a lot of other benefits from that. Insurance companies, they make more, insurance costs come down because the possibility of the insurance premiums reduces. Your fleet becomes much better because your availability is higher. Roughly, we if we have 100 buses, only 95 are on the road. 5 buses are being maintained because of accidents or something. If we can prevent accidents, we have more buses on road, more assets on road. So it has benefits all over the place. So it's not just safety oriented, it has a real bottom line impact on public transport businesses. Next. Again, on the safety side, detection defects. Some of the experiments in Japan, they are using cameras on board the buses and trains, which are looking at track cracks on the track and looking at any of the sleeper defects and all these things using lidar cameras, and then reporting this aberrations or even the health of the system on a real-time basis. This used to be a huge challenge in public transport, again, because your assets are all over the city and doing it manually is literally impossible. So the machine-based systems are becoming much more powerful. Some of the experiments in Spain, in Barcelona, what they have done is they are also looking at people who evade fares, people who don't pay for their journeys, and using camera-based detection systems and then catching them. And they have managed to reduce the fare evasion significantly, almost complete elimination of fare evasion by using such control systems. So again, you're creating much safer systems, because often it is people who evade fares are the kind of people who also create trouble. There's a very heavy correlation to these two. So when you start to put a proper management, if you know what is a broken window syndrome, you will understand. So if you control your fare collection system or fare evasion system, then you also create a much safer system on the trains. So there is a huge opportunity of these various technological deployment to create better cities, better environment, better vehicles. And again, idea is that if you would be able to move from A to B in a much better fashion. So mobility is where we need to focus in our new world and smart city, rather than movement of vehicles per se. So with that, I think that's my last slide. Thank you.